All right, so this is the first part of example 4, and I wanted to break this down into separate videos because I really wanted to break this down into detail, and so I thought it'd be easiest to have shorter videos rather than one really long video. Okay, so I wanted to look at Descartes' rule of signs. That's what would be the first thing you would do if you were going to do this, and this will help us determine how many positive or negative zeros there are. Okay, so um, and what you can also do is look at the degree of the polynomial. Notice that this is a degree 4 polynomial, and we see that by the leading term. We have a degree 4 because we have a 4 exponent. So that tells us, since we have a degree 4 function, that tells us that there's at most 4 zeros. Okay, so keep that in mind. Since we have degree 4 for this function, there's at most 4 zeros. Okay, so keeping that in mind, we'll go into now the Descartes' rule of signs. So Descartes' rule of signs, I'll write that down. So Descartes' rule of signs. We look at the function p of x, which is just itself, and we want to see how many sign changes we have. Okay, so notice that this is positive, 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 positive. Okay, so there's no sign changes. It's always positive. It never switches from positive or negative to or negative to positive. So that tells us, this tells us that there's there's no positive real zeros. So we don't have to consider any positive real zeros. Okay, so that's really nice once we get into the rational zero theorem, because once we get all the possibilities, we can just ignore all the positives because we have the plus or minus of every possible rational zero. Well, no, there's no positive real zeros, so we can just cross out all the positive and just consider the negatives. That's what's really nice about Descartes' rule of signs. We can eliminate a lot of possibilities by looking at this. Okay, so now we want to look at p of negative x. P of negative x is equal to 3 negative x to the 4th power plus 23 negative x to the 3rd, 56 negative x squared plus 52 times negative x plus 16. Okay, so this will equal, this does not change signs. This will change signs since it's odd. This will not change signs. This will change signs. And this will not change signs. So we go from, I don't know why I said that, but this is actually, might be scratching your head here, but there's no negative there. I don't know why I wrote that down. Okay, so this goes from positive to negative, negative to positive, positive to negative, and negative to positive. So there's either 4 or 2. So we're talking about negative real zeros, there's either 4 or 2 negative real zeros. So that's what we've determined. No positive real zeros, and for negative real zeros, it's either 4 or 2 of them. Or actually, no, or 0. It could be that there's no negative real zeros. So we have to subtract 2 until we get down to 0. So 0 is a possibility. So it could be 4, 2, or 0 negative real zeros. Okay, so hopefully this makes sense. And if you have any concerns, let me know. We're going to move on to the next part of this, dealing with the rational zero theorem.